Okay, today we're going to start talking about surface area. And the word surface is, if you think about what it is it's kind of like what you can touch and it's around the outside, that's the surface. So volume was the space inside, and surface area is like the amount outside. And so we could take any shape and cut it with scissors and then lay it flat, and we could think about surface area that way. Area is the amount of space that takes up a two-dimensional shape. So it's like covering, amount of space covered. Covered. And so total surface area would be the area of all of the outside surfaces of a three-dimensional shape. Remember from our volume lesson how we name a shape? We name a shape off of its bases. There are two congruent bases, and we look and we figure out what two sides are congruent. Sometimes there's more than two sides, but if there's exactly two that are congruent, those are our bases. And so we name it off of the bases. And then why is it important? Because that base, I'm going to have to find the area of that base, and each shape has a different area formula. Okay, so the rectangular prism, I can see that I have a top and a bottom, two exact congruent bases. And it would be this bigger rectangle and that bigger rectangle. Those are the bases because there's only two of them and they're congruent. So I have two triangles. Since there's only two, those are my bases. And so this is a triangular prism. Two trapezoids, trapezoidal prism. Two pentagons, pentagonal prisms. Two circle, it is not a circular prism, this one's special cylinder. And then two triangles makes a triangular prism. So area of a rectangle, area of a triangle, area of a trapezoid, area of a pentagon, area of a circle, area of a triangle. All those things are different formulas. So it's really important that we're able to name the shape. Okay, let's do a couple problems. We can use the formulas off of the formula chart, which I'm going to do. Or you can find the area of each one of these parts and add it up. Either way, we're going to get the same thing. Using the formula is a little bit shorter, well, a lot shorter, because I'm not having to find the area of each one. So for this one, I'm going to look on my formula chart and I'm going to find surface area, total surface area of a rectangular prism. That's important. By the way, here's my base. Okay, because I'm going to be finding the area of that base and the perimeter of that base. So my base is a rectangle, and so big B is the area of that rectangle, which is length times width. And the perimeter is adding up all the sides of that rectangle, or 2 times the length plus 2 times the width, either way that you want to do it. Because the formula says this. The formula says the surface area of a rectangular prism is 2 times the area of the base, because there's two bases, that makes sense, plus the perimeter of the base times the height of the prism. So first I need to find the area of the base, which is that rectangle that I have outlined. You can shade it in or outline it. So the area is length times width, which is 72. So big B is 72. The next thing I need to do is find the perimeter, which is 2 times the length plus 2 times the width, or you can go around and add 9 and 8 and 9 and 8. Either way, it's 18 and 16, which is 34. And then I'm going to plug it into this formula right here. 2 times 72 plus 34 times the height of the prism. The height of the prism is how far the top is from the bottom. Well, here's the top rectangle, and there's the bottom, and the distance between them is 5. So I can punch that in my calculator just like this. I'll go, if I can get it to come on, 2 times 72 plus 34 times 5. And so the total surface area of this rectangular prism is 314 square kilometers, and it's squared with area. Okay, let's try another. Let's name it so we know what our bases are. Remember, there are 2 congruent bases. Well, what 2 things are congruent? This triangle and this triangle. So this is a triangular prism. And so I need to be able to find the area of the triangle. So look on my formula chart, and I know the area of a triangle is 1/2 base times height of the triangle. By the way, here's my triangle bottom right here. Alright, so the formula for the surface area of a prism is 2 times the base, area of the base, because there's 2 bases. So 2 times the area of the base plus the perimeter of the base times the height of the shape. First thing I want to do is figure out what big B is. Here's my formula. So big B is 1/2 the base of the triangle. So look at your picture. What's the base of the triangle? It's 12 times the height of the triangle. The height of the triangle and the base of the triangle make a 90-degree angle. So the height of the triangle is 9.1. So I'm going to find big B first. And that's 54.6. Now I need to find the perimeter of the triangle. Here's the deal. I know this side of the triangle is 12, and this side of the triangle is 10, and they make a 90-degree angle. So I'm going to have to do, oh, that doesn't make a 90-degree angle. I know this side is 12, sorry. Okay, so I'm looking at my picture. This is 12, that's isosceles. And this is 10. So the perimeter is going to be 34 because 12 plus 12 is 24 plus 10 is 34. So the perimeter is 34. So I'm going to use these 2 numbers and plug them in here. So my surface area is 2 times what I got for the area, which is 54.6, plus what I got for my perimeter, which was 34, times the height of the prism. How tall is that prism? Well, how far is it between the 2 triangles? Well, it is 11 between the 2 triangles. So I'm going to put this in my calculator. And I got the total surface area of this triangular prism to be 483 and 0.2 inches squared, or squared inches, because area is always square. Okay, so before we go on to the next and the last example, let's talk about it. This takes a little bit more than the volume, but it's still pretty easy. We're still having to go through the steps of finding big B, which is the area of the base. And to find the area of the base, I actually have to look on my formula chart and see what formula to use. So I want to find the area of the base. Then I want to find the perimeter of the base. Make sure you're doing the area of the base and perimeter of the base, not the perimeter of anything else. And then also be able to look at the picture and determine the height. And remember, the height is the distance between the two bases. Whatever you named your shape, you named it off of your bases. You know it's that distance between those two shapes. All right, let's try one more. Okay, so far the prisms, we could have found the area of each part of the prism and then added each one of those areas up. To me, that takes a lot longer because I'm using a lot of area formulas and then a lot of addition. The way I did it, all I had to do was find the area of one and then find the perimeter of that same one, which was the base, and then I plugged it into the formula. So this is a cylinder, which is not a prism. And if you look on your formula chart, it gives you the formula for that, and it's a little bit longer. It's actually going to be 2 times the area of the bases, which is 2 pi r squared, because the area of a circle is pi r squared, plus the circumference of the circle, which is 2 pi r, that's how you find the circumference of the circle, times the height. So it's really the same formula, 2 times the area of the base plus the perimeter times the height. But the perimeter of a circle is called circumference. So it really is the same formula, but because we don't call the circumference of a circle perimeter, it looks different, but it's really not. It's still the perimeter times the height, which would be circumference. So if you look on your formula chart, it looks uglier than this, but it really is 2 times the area of the circle plus the perimeter of the circle times the height. But remember, perimeter in this case is circumference. So on your formula chart, it looks like this. It looks like 2 pi r squared. Well, pi r squared is the area of a circle. Plus 2 pi r. Well, 2 pi r is the perimeter of a circle. The perimeter of a circle is called circumference. H, and H is the distance between the two bases. So really, those formulas for surface area are the same. They look different because the area of a circle and the circumference of a circle look different. Okay, so to me, even though it looks harder, it's really not. It's easier because I only need to deal with radius and height. We are going to leave this in terms of pi. So my radius is 12 and my height is 10. So let's plug that in. So I got 2 times pi times 12 squared. 2 times pi times the radius squared, my radius is 12, plus 2 times pi times 12 times 10. Now, if I'm leaving in terms of pi, I am not going to put a number in place of pi. I'm just going to kind of ignore it for right now. So I'm going to go 2 times 12 squared, which should be 288. Now I'm going to put the pi on the end. Plus, now I'm going to ignore the pi, and I'm going to go 2 times 12 times 10, which should be 240. And I'm going to put the pi on the end. So I'm not really doing anything with the pi. It's kind of like having inches, and I'm putting inches on there, or some unit. And so now I'm going to add that together. 328, 528 pi. If I did that right. Yes, that's right. So the total surface area of this cylinder is 528 pi feet squared. Okay, so total surface area. You want to name the shape because it determines its bases. Why do we need that? Because we're going to find the area of that base, and then we're going to find the perimeter of that base. And it doesn't matter what shape we're talking about. Even with the circle, we found the area of the circle, pi r squared, and the perimeter of the circle, 2 pi r. Okay, and so plug the numbers into the formula and work it out. with a cylinder for right now, we're just going to ignore the pi. We're carrying it along. We're leaving it in terms of pi. Okay, so now you need to summarize the video in 2 to 3 sentences, and then you also need to write at least one question. It's either a question about something you didn't understand and you need me to go over better. If you need me to work another example, or maybe, which would be even better, write a question you think I might ask the students in the class.